I decided to make this review for the 3 sections of Chapter 3 where students were having the most trouble. So that included 3-3, which has converse theorems and postulate, 3-4, which has perpendicular theorems, and 3-6, which is writing equations of lines using the information that I've written below, where we need to memorize certain formulas. The formulas you should memorize are slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Point slope formula, y minus y1 equals m parentheses x minus x1. And slope intercept form, y equals mx plus b. So converse theorems from 3-3 are used to show or prove lines are parallel. So if you look at our figure here with 2 lines cut by a transversal, these lines do not state that they are parallel. So we can't really say angle 1 is congruent to angle 5 unless they're parallel, or we could say the lines are parallel because angle 1 is congruent to angle 5. So, looking at number 4 here with the angle 1 and angle 5, angle 1 and angle 5 should be alternate exterior angles. They would be congruent if the lines are parallel, but vice versa. Since we know they're congruent, then we can say those lines are parallel because of the converse of alternate exterior angle theorem. Remember, the only one that is a postulate for these are corresponding angles. Okay, so for number 5, hopefully you got converse of same side and interior. 3 and 4 should be same side interior. Since they add up to 180, then those lines must be parallel. Number 6, angle 3 is congruent to angle 7. Since we know that they're definitely congruent, then the lines must be parallel because of converse of alternate interior angle theorem. For 7, 8, and 9, I'll do number 7 for you guys. You're going to take, you're going to take this 5 that they give you at the end when they tell you x equals 5. You're going to take that 5 and you're going to plug that into each of these. You're going to find the measure of angle 4, plug it into this one, find the measure of angle 8, and then from there, determine which converse theorem could prove that the lines are parallel. (13 times 5 minus 4). 13 times 5 is 65, minus 4 is 61 degrees. Do the same thing to find the measure of angle 8. We have 9 times 5 plus 16. 45 plus 16, 61 degrees. So angles 4 and 8 are alternate interior, so they're supposed to be congruent. Since we know that they're congruent, we can then say that the lines are parallel because of converse of alternate exterior angle, 8 and 4 interior. Converse of alternate interior angle theorem. So go ahead and try number 8 and 9. Pause this video, try 8 and 9. Okay, so you should have completed numbers 8 and 9 by now. When we plug in the value, we end up with, 6 times 17 is 60 plus 42, 102 plus 37 is 139. And over here, 9 times 6 is 54, minus 13 is 41. And so these two things add to 180. So measure of 8 and measure of 7 are same side interior, so they should add to 180. So 8 is that they are parallel by converse of same side interior angle theorem. Okay, for number 9, when we plug that 5 in, 5 times 25 is 125, plus 7 is 132. For measure of angle 6, plug the 5 in, 24 times 5, I'm blanking out, 20 times 5 is 100, 4 times 5 is 20, yes, 120, plus 12, which is 132. So angle 2 and angle 6, when I look at angle 2 and angle 6, they should be congruent, as they are. And if they are congruent, then the lines are parallel by converse of alternate exterior angle theorem. For 3-4, we have two types of problems that we're going to need to be able to do. The first one is to find a shortest segment. A shortest segment forms a 90-degree angle. So PB in this case is the shortest segment. And then also we need to write an inequality. Since PB is the shortest segment, then it must be less than, since it's got a value of 5, I put 5, it must be less than the longer segment of x plus 3. To solve for x, we subtract 3 from both sides. 2 is less than x. Now with an inequality, we need to have our variable first, and so we're taking this whole thing and flipping it around. 2 less than x would become x is greater than 2. We actually need to flip that inequality sign. Okay, for the 3-4 perpendicular theorems, this first one says two intersecting lines form linear pair of congruent angles, then the lines are perpendicular. So if there's two intersecting lines formed by, if two intersecting lines form a linear pair of congruent angles, so here we have a linear pair, these two angles are congruent, then the angle, then the lines are perpendicular. So since we have a linear pair, which is 180 degrees, and this is cut in half because we have two of the same angle measurement, well, 180 cut in half, so we have two of the same angle measurement, would have to be 90 each. And so therefore, the lines must be perpendicular. Perpendicular transversal theorem says if we have these parallel lines and a transversal is perpendicular to one of those parallel lines, not both, then it is also perpendicular to this one right here as well. And for the last one, if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. And this makes sense because if we have two perpendicular angles, these are actually corresponding angles. And so the converse of corresponding angles postulate in this case would tell us that R is parallel to S. From the previous slide, please select which perpendicular theorem is represented by each of these photos. Pause the video and write down your answers for me, please. So for the perpendicular theorems up top, we have a linear pair, and so that was that first theorem about linear pair. And on the bottom, we don't have parallel lines, but we do know that the two angles are perpendicular. And so this was our last theorem that states that we can then show that these lines are actually parallel. So in this case, neither of these were the only theorem that has a name, perpendicular transversal theorem, which showed up on your previous test. These scenarios were presented in the 3-6 video, which can still be found on the Sunday Post from a couple of weeks ago. That may help you review the topic now that you know more about it. It may sink in a little bit better as you watch that video once again. So in example A, we're given a slope of 3 and a point. Since we're given the slope and the point, we're going to start with point-slope form. In fact, in this problem, they're only asking for point-slope form. So once we plug in those numbers into the point-slope formula, we are done with the problem. In example B, we're given 2 points, but we don't know the slope. So we're going to need to calculate the slope first. Once we calculate the slope, we can then use either, with the examples being shown here, plugging directly into y equals mx plus b, or a lot of you are more comfortable with using that point slope form than distributing and isolating y. In example C, we're given an x-intercept and a y-intercept. This was almost exact to what was on our test, actually. We need to make an ordered pair for each of these. So think for a second, what would be the x-intercept 2 as an ordered pair? Okay, and what would be the y-intercept of 3 as an ordered pair? And both of these are actually listed right here, 2, 0, and 0, 3. So using those points, we can now calculate slope, and then we're going to pick one of those points. So say I decide to pick 2, 0. Then I would plug in the 2 and the 0, just like they did here, actually. Plug in our slope. Since they wanted it in point slope form, that's all we have to do at that point. If they wanted it in slope intercept form, we would distribute and isolate the y. Okay, for these problems, in order to determine if the lines are parallel, intersect, or coincide, we need to do a few things. First, we need to always isolate y. Okay, after that, we need to know what parallel means. Well, that's the same m, same slope. Intersect would be not parallel, so not m. And coincide is the same line. If you ended up with y equals 2x plus 4 and you already had a y equals 2x plus 4, once we isolate y, then since those lines are exactly the same, they have the same slope and the same y-intercept, they coincide. Please complete numbers 19 through 22. We can check our answers using the textbook.